Hello, welcome to a video about domain and range of composite functions. So we're going to do this algebraically to start and then jump to the graphs, the fun ones. So what we're going to take a look at and how we're going to really do this is trying to think of it as I call it a function machine model. So let's analyze f of g of x, okay? Now, the way this is written, g of x is really the input into f of x. So if we're thinking values go through this machine in this direction, right? We have to start the domain of g of x, right? So all the values that g of x can accept, right? That won't make the expression undefined. It goes into g of x, right? Then things come out, right? So this is the range of g of x, right? Those things that come out of g of x, right, are inputted into f of x. Now here's the thing, right? It all seems well and good, right? Because then when you have your result, you get the range of f of g of x. But right here is where things can go awry. This is where the machine system, this back-to-back machine system, can break down. Because, in theory, we may need to restrict these values right here, right? In other words, things that come out of g of x may not be able to go into f of x, okay? So things that come out of the first machine might make the second machine break. And in turn, we may need to adjust the domain of g of x to see, okay, if there are certain things that cannot come out of this machine here, we may need to take stuff out from the very beginning, okay? We may need to restrict these values because not all values here are going to work into here. So this is a little bit of a puzzle, right? It makes more sense when we do an example or two, but that's the big idea, okay? So let's check it out. You have f of g of x here, right? And we have these 6 functions. If we did f of g of x, well, all right, we've got f of g of x. So I'm going to replace g of x with x squared, right? And f of x says take the input and add 2, right? Input and add 2. So this is going to be x squared plus 2. All right. If we did this little function machine thing here, right? And we did g of x is the first thing that's going to, happen, right? I'll keep it as black. Right? We're going to put values into g of x. They're going to come out and go into f of x, right? Well, the values that g of x is allowed to accept are all real numbers, right? Okay, so now what comes out of g of x? Well, g of x is x squared. So that's the rule in there. And when you square anything, right, in the real number system, you're going to get 0 at the lowest up through infinity. So that's what comes out. Now I have to ask myself, if 0 to infinity is being inputted into f of x, right, what's going to come out? Now, it might be helpful to think, okay, what's the very lowest that can come out, right? Well, if I plugged in 0, right, into f of x, right, I'm going to get out 2, right? This function right here is x plus 2 alone. So when we plug in 0, we get out 2. When we plug in infinity, it doesn't make any sense, right? You can get anything up to infinity. So the very lowest that could come out is 2. Now that should make sense when we think of the fact that f of g of x we figured out is x squared plus 2, right? The very lowest you can get out is 2 if x was 0, right? So now our domain is everything that came in originally. So I'm going to shorthand it throughout this video here and write that the domain D is negative infinity to infinity, right? An interval notation. And what comes out of this whole machine is the range, okay? Right? And again, it may make sense to think of it just as this simplified function here, but I think it's going to be helpful to imagine this kind of back-to-back function machine here, especially when we get to the graphs, okay? Let's try another one here, and then you guys can try 3 and 4. So let's do g of f of x, okay? G of f of x, well, that's g of x plus 2. So this is the reverse order, right? F of x is what goes inside, and g of x plus 2 is x plus 2 squared. We can FOIL that and get this, right? But it might not be obvious what the domain and range or what the values that come out of this would be, so let's make a little machine, all right? Now the first thing we're inputting here is putting values into f of x. So if I put any value into f of x, which f of x can accept anything, right? It's x plus 2, and it can accept negatives, positives, 0, whatever. Everything's going to come out, right? There's no holes or, values that we can't accept. Now, if I plug in negative infinity to infinity into g of x, well, g of x is x squared. So just like we talked about in number 1, the things that can come out of here are 0 to infinity. The lowest value you're going to get out plugging anything into x squared is 0, right? So now we've got our domain and range. So in this case, it may not be obvious right now why all the outputs of that expression are 0 to infinity. But from this, it may be obvious, right? Because if you're squaring anything, the lowest you can get is 0 all the way up to infinity, okay? Now, I mentioned that we might actually stop for a second and try number 3. Okay, so let's see how we did for number 3. This is where we have to start to be a little bit careful, right? So f of h of x here is square root of x, right? And all we're having to do with all that f of x tells us to do is add 2 to the input. So we're going to take square root of x plus 2, right? All right, so now let's make our input and output here, h of x and f of x, right? H of x is square root of x, f of x is x plus 2. Now the only things that are allowed to go in to the square root of x are 0 to infinity, right? You cannot plug in a -1. You can't plug in any negatives into the square root of x, right? All right, so now what comes out? Well, take the square root of anything. Square root of 0 is 0 all the way up through infinity. Okay. Just like we did in the one above, a similar sort of things come out. And actually, it turns out to look very similar to the last one we did. If I plug in a 0, the lowest I can get out is a 2 all the way up through infinity. So again, the domain is 0 to infinity, and the range is 2 to infinity. All right? Now here's where things get a little bit funny, and this is a really good lead-in to what we'll look at when we do the grasp. But let's do a couple more equations. H of f of x. Now, f of x we know is x plus 2, right? And h of x plus 2 is the square root of x plus 2. Now, we can do this a couple ways. Reason to yourself, what's the lowest value you can substitute into this function? Well, if I think about it, the lowest value I can put in is negative 2. If I put negative 3, or negative 2.1, or negative 2.001, I'm going to get a negative inside a radical. That's no good. If I were to put these back to back, right, f of x is x plus 2. I can put whatever I want into that, negative infinity to infinity into x plus 2, and I'll get negative infinity to infinity out from here, right? However, if I put h of x and I put that back to back, that's no good, right? H of x cannot accept all of these. So I have to modify this, right? This can only accept 0 to infinity. Only values that will work for h of x, right? And we can see that the only values that will come out are 0 to infinity, right? If I plug in 0, I get 0 all the way up to infinity. But that means I need to go back and restrict this, right? So I have to ask myself, if I get out 0 through infinity, what did I plug in, right? What was it that 0 to infinity came from? Now, if I got 0, I must have plugged negative 2 into the function, right? I must have done negative 2 plus 2 and gotten 0 all the way up through infinity, right? And that checks out with what we said initially was, you know, in this function, the lowest value I can plug in is negative 2. So that is the domain of the entire composition, right? So now we've got our domain checking out. Sometimes the domain can be easier to find by analyzing the function, the algebraic expression itself. But there you go. Okay. All right. So let's try 5 and 6. Do your best with 5 and 6. There are some other ones we can practice over here, but we'll leave it at 5 and 6 for now and see how you do. All right, so go ahead and try 5 and 6. All right, let's see how you did. So you have g of h of x. That's g of, oops. Sorry. You have g of square root of x. And so if you look back up here, g of x is x squared. H of x is the square root of x, right? So we have g of the square root of x squared. Oops, sorry. G of square root of x is the square root of x squared, which equals just x, right? But there's a caveat here, right? This is where domain and range are really important. If you're just analyzing this and saying, oh, you know what, this is x, right? Well, let's see what you can plug in for x, right? Because we know x could be anything theoretically on its own, but the way we constructed this function, let's see what we have. So h of x is the innermost, and then g of x is over here, right? We'll plug stuff in for h of x. So what can go into h of x? Anything from 0 to infinity. What can come out? 0 to infinity. Right? And again, if you want to label up h of x as the square root of x and g of x is x squared. If you square 0 to infinity, well, you get 0 to infinity coming out, right? So that's going to tell us what our domain and range is, right? Notice how that's not obvious from this by itself, right? So I'll get rid of the asterisk. But like g of h of x, it does simplify to x, assuming that you're plugging in numbers that are acceptable, right? Which in this case are anything that's non-negative, right? Okay, so let's do one more. Let's jump to 6. See if we can figure this one out, and then we'll wrap this video up. So we have h of x squared is the square root of x squared, and here is where we've got to be really careful, right? Because the square root of x squared, it's very tempting to call it x, right? But think about what could go into this function, right? If you plugged in -3, let's say, right? If you did h of g of -3, you would be getting h of -3 squared, which is 9, and h of 9 is, the square root of 9 is 3. So notice what happened. You plugged in -3 and you got out 3, right? That means that plugging in x does not guarantee that you're going to get that same value out, right? In this case, squaring the -3, right, and then taking the square root will always result in a positive. So the way we handle that is by saying that this is really the absolute value of x, right? And this can help us in a couple ways, right? This is something that comes up a lot, right? We can't just say, oh, square root and squared cancel out and call it x, right? No, if x was a negative, right, then when it actually gets simplified, it'll turn into an absolute value. Now, we're going to learn about this later as the even odd rule, but for now, let's analyze it with our composition, right? You have g of x going in first, and then h of x going in next, right? You've got -infinity going into this function of g of x here. G of x is x squared. So when you square things, right, you make them non-negative in the real number system, right? And that means when they come out, when they go into h of x here, so square root of x, they come out as 0 to infinity, right? So our domain is -infinity to infinity. You can plug in whatever you want. And the range is 0 to infinity. So the only things that come out are positives, and that should match up with the fact that it's the absolute value of x, okay? So hopefully this helped. We have some more practice for the algebraic ones, but the next video will be about graphs.